Okay, good afternoon, everyone. These problems were solved as a part of our regular classwork. However, some students did not get the opportunity to see these solutions because of the ins and outs and ups and downs with the internet. So we're just going to do them immediately. And I have right here my assistant, or I am his assistant because he's the one who is going to be telling me everything that I need to do in solving these equations. Okay, first one, pair of simultaneous equations, of course, and that's what we're looking at. So we need to solve this pair of simultaneous equations. And I'm just taking a look at this, and I see that we have x here and we have 2x. Therefore, it would make a lot of sense just to multiply this equation by 2. Right? But what makes more sense to me is to divide this equation by 2. Now, if we would encounter any fraction, then I wouldn't divide by 2. But I see that this equation is a multiple of 2. So we can divide here 2x by 2, 2y by 2, and 6 also by 2. So I will go straight ahead to divide equation 2. So equation 2, and I will divide that by 2. And when I divide that by 2, I get x minus y is equal to 3, and that is our equation 3. Now, what do we have here for the x's? They are the same. So here's our question. In order to eliminate the x's, do we subtract or add? Alright. My best bet is that we're going to subtract because we only add when we have additive inverses. Right? So we don't have additive inverses. These two are exactly the same. So we will subtract one equation from the other. This equation is the one that was used already. As a matter of fact, it yielded this equation. So this one is out of the running at the moment. And of course, these two are exactly the same. So my question is to you, do we say x? Let's say that again. Do we say equation 1 minus equation 3, or we say equation 3 minus equation 1?
Equation 1 minus equation 3.
Right, because we're going to say equation 1 minus equation 3. So by saying that, we'll have x minus x, the x's are gone. Then we say 3y minus what? Right, minus y. So it's going to be 3y minus negative y, and that will give us 4y. And that is equal to 7 minus 3, which is equal to 4. And you will tell me what y is equal to.
Y is equal to 1.
Y is equal to 1. Which equation do we put that into? The simplest equation. We have equations 1, 2, and 3. Which equation is going to be the simplest? If we have the value of y, that will give us right equation 3. That's right. So equation 3. So this is the equation 3 that we are focusing on for y is equal to 1. So we have what? X minus y, which is y of course is equal to 1, is equal to 3. And we can see very clearly, immediately, what x is equal to. And what is x equal to?
X is equal to 3 plus 1.
Which is, I don't know what 3 plus 1 is. Okay, x is equal to 4. Right, x is equal to 4. So we declare that x is equal to 4 and y is equal to 1. What do you notice here? Because we're going to go immediately to the next one. What do you notice here?
Similar equation.
Okay, good. But they have have different signs. Additive inverses. So they are additive inverses.
So is the y and the 3y.
Well, these have different signs also, but they are not additive inverses because they do not have the same size. But these are additive inverses because they have the same size and the signs are different. Therefore, these two may be eliminated immediately. The x's may be eliminated immediately by adding the two equations. So we don't have to multiply anything. So we say equation 1 plus equation 2. What will happen? Additive inverses will take care of each other. So the x's are eliminated. And what about the y's? What we are going to be adding? We add a negative y with a positive 3y, and what will be the result? So that will be a positive 2y, because the coefficient here is negative 1. The coefficient here is positive 3. When we put them together, we get a positive 2. So we'll have there 2y. And 2y is equal to 6. So we add these, we get 2y. And then we add these, and we get 6. So what is y equal to? Y is equal to 3. And which equation do we put that into? Repeat that, please. You put that into equation 1. That's what I would do too. I put that into equation 1. So I will say, put this down. I will say for equation 1, 2x minus 3 is equal to 1. So what do we say in addition to that? Right. So x is equal to, we're going to eliminate this negative 3 by addition, so we'll get plus 3. So it's going to be 1 plus 3, which is 4. If we want to write that, we may. And then we will divide or eliminate this 2 by division, so we'll have x is equal to 2. It's equal to 2. So we will declare x is equal to 2, y is equal to 3. What about this one? What do we do?
3y, the positive 3y and the negative 3y are additive inverses.
Alright, so positive 3y and negative 3y are additive inverses. Therefore, if we add the two equations, they will have a cancelling effect on each other. So we may go straight ahead and add the two equations. Equation 1 plus equation 2, and we know that these will have a cancelling effect on each other. And we have x plus 2x. And what is x plus 2x?
X plus 2x is 3x.
So we're going to have 3x there. And then we'll have 12 plus 6. And what is that equal to?
18.
18. Therefore, x is equal to?
6.
X is equal to 6. Into which equation do you think?
6 into 2.
You're going to put that into equation 2? I'm going to put that into equation 1 because as far as I'm concerned, equation 1 is simpler. So I'm going to put that into equation 1 by saying x is what? 6. So 6 goes there, plus 3y is equal to 12. So 3y is equal to what?
3y is equal to 6.
Yes, we will eliminate the 6 from this side by subtraction. And we subtract 6 from the right hand side also. Here we have 3y is equal to 6. So y is equal to?
Y is equal to 2.
Right, so we have x is equal to 6. Y is equal to 2. Here we have the solution of our first 3 problems in the classwork that some of the students missed on the last occasion. So we will continue with the other 3. Now this is classwork, but some students missed out on it. So I'm just taking the opportunity to ensure that they have an audio visual on it to watch, so that they don't miss anything. Alright, so we let us put there number 7, 9, and 11. So number 7, we have 2x plus 3y is equal to 1. And we have 5x plus 3y is equal to 16. Equation 1. Equation 2. Take a look at that. Number 9 is my favorite. X minus y is equal to negative 2. And 2x plus 3 is equal to 1. 2x plus 3y is equal to 21. And then finally, number 11, 5x minus 2y is equal to 31. And 4x plus 3y, I think, is equal to 11. That's the equation 1. That's the equation 2. Alright. Let's go straight to number 7. What do we say? You'll eliminate the x's? Would you? Okay, you will eliminate the y's. Okay, so we'll eliminate the y's, and the coefficients of the y's are exactly the same. So what do we do in order to eliminate the y's? Correct, so we will subtract. We will subtract because they are exactly the same. If they were additive inverses, then we would add, but they are exactly the same, so we will subtract. So we'll say, do we say equation 1 minus equation 2 or equation 2 minus equation 1? Right, because by so doing, you stand a chance of getting positive terms. So we'll say equation 2 minus equation 1. And what do we have? 5x minus 2x, that will give us 3x. And of course, the system was designed that the y's will be eliminated by subtraction. And then we have 16 minus 1, and that is 15. And x is equal to what? X is equal to 5 into equation. And here that 2? Anyone that you prefer? Did you say 2? Into equation 2. So we're going to put that into equation 2. So right there, 5x. So 5 times 5 plus 3y is equal to 16. See, we have replaced the x with the 5. So this is going to be 25 plus 3y 16. And we say that 3y is equal to what?
3y is equal to
16 minus 25, which will give us a negative 9. So y is equal to negative 3. So we declare that x is equal to 5 and y is equal to negative 3. Alright. Tell me what to do with this one. Can anything be eliminated immediately? No. Nothing can be eliminated immediately. So what do we say? What do you do in order to get the coefficients in such a way that you may eliminate? First of all, you have to do some multiplication in order that the x's, this x will be the same as this, or something that will work for the y's in order that they may be eliminated. So we might do either of two things. We might multiply equation 1 by 2. If we multiply equation 1 by 2, we will get 2x and we'll get 2x. Correct? If we multiply equation 1 by 3, we'll have a negative 3y and we have a positive 3y. Alright, so multiplying by 2, we'll have the 2x and the x's will be ready to be eliminated. And then if we multiply by 3, then the y's will be ready to be eliminated. So my question to you, do we multiply by equation 1? Do we multiply equation 1 by 2 or 3? Which one do we prefer? I have my preference. Multiply equation 1 by, so equation 1 will be multiplied by either 2 or 3. What do you say? You say 2, and I will say 3. And the reason for saying 3 is that although 3 is larger, but it's not like astronomically larger, right? So it's just larger. It's also, when we multiply this by 3, we're going to get a negative 3y here. So these will be eliminated. They are additive inverses. When you get additive inverses, it is easier to use additive inverses because they will have a cancelling effect by addition. So it's always easier to add than to subtract, especially when you are manipulating positive and negative numbers. It's always easier to add than to subtract. Okay? Alright, so we're going to multiply that by 3. When we multiply by 3, we get what? 3x minus 3y is equal to negative 6. So we multiply this by 3, we multiply this by 3, and we multiply this by 3. Then we have equation 3. Now, notice that these are additive inverses, which is better to have than to have them be the same, because it's always easier to add than to subtract. So we'll go straight ahead and say equation 2 plus equation 3, because these are additive inverses. And we'll have a cancelling effect on each other on addition. So when we add these together, what do we get? 2x plus 3x, we get what? 5x. What about 21? When we add 21 with a negative 6, what do we get? That's correct, 15. Therefore, x is equal to what? X is equal to 3 into equation? You're going to put that into equation 2, no problem. So let's see, we have, put that into equation 2, we have 2 times x, 2x, and x is equal to 3, plus 3y is equal to 21. going to try a different trick on this one, right? I realize that we have a 3 here, a 3 here, and a 3, a multiple of 3 here. So we're just going to write that simply saying that divide straight through by 3. So when we divide through by 3, we just get a 2 there plus y is equal to 7. So y is equal to? So y is equal to 5. So we declare x is equal to 3 and y is equal to 5. As we see, there is no additive inverses and no two coefficients are alike. Therefore, we will have to do some multiplication. So you will tell me what we will multiply by. Now, if we multiply these two equations by 5 and 4, although there is no great disparity between multiplying by negative 2, multiplying by 2 and 3, these numbers are still larger. So the numbers are still larger. So I wouldn't want to multiply by larger numbers if I can multiply by smaller numbers. So I would want to multiply by the smaller numbers. Additionally, if I multiply by the smaller numbers, in order to eliminate the y's, we will get additive inverses, which is always simpler to manipulate. It's always simpler to work with the additive inverses. So we are going to say equation 1, we are going to multiply that by 3. So we'll get 15x minus 6y is equal to, multiply that by 3, you get 93. And that is equation 3. Then we say equation 2, that we'll multiply by 2, and we'll get 8x plus 6y is equal to 22. And that will be our equation 4. So now that we have additive inverses, there is no doubt as to what to do with the two equations. Equation 3 plus equation 4, and what will we get? 15 plus 8. So that will be 23x. The y's are eliminated by addition because they are additive inverses, and we'll get 5. 150. That's nice. So what is x equal to? The number seems large. The numbers seem large. So we think that we probably need to hesitate for a few seconds. But if we look at this, we'll see that what? 15 is 5 threes. And then this is the 100 part, which is 5 times 20. So we are sure that x is equal to 5. Yes, x is equal to 5. Into which equation? Equation 3 is too large. I think that I'll go with equation 2. So I'm going to put that into equation 2. You want to put it into equation 3? The next thing that we are going to do will require or make use of equation 3 to some great extent. So you'll have no difficulty with that. So into equation 2, what do we say? Four times 5 plus 3y is equal to 11. Which one is similar to it? This one. So what do we have? 20 plus 3y is equal to 11. So 3y is equal to, we're going to see subtracting 20 from both sides, negative 9. So y is equal to negative 3. So x is equal to 5, y is equal to negative 3. Fine. That's all there is to it. So these are the problems that were done in class, for the classwork for some of the students who did not get the opportunity to do their classwork or to see the solution of those problems in class, there we have them in your audiovisual that you may take advantage of that as soon as we have them uploaded. As a matter of fact, there is no one in. Let me see. Okay, right. So that is all there is to it, and we are going to take a look at something else that was done in class that we also need to have on that YouTube.